Hello, Honors Physics class. It is Mrs. Mills. I am going to do a little lecture for you today on charges. How do you determine what the charge is on a particular object? This is kind of the beginning of our new unit on static electricity. Hopefully this will not last more than a few minutes, and then you will have a worksheet to work on. So, and I'm also hoping a lot of this is going to be review. It is probably a good idea for you to take some notes while you are writing this, while you're watching this. So let's go ahead and begin with the concept of charge. So to understand this concept, you have to understand an atom, and I believe most of us remember the basic layout of an atom. So in the inside, in the nucleus, are your protons and your neutrons. And your protons have positive charge and the neutrons don't have any charge. And on the outside of the atom lie the electrons, which are orbiting around our atom, and they're typically in this area called the electron cloud. So if we drew this kind of a little bit differently, this would be your electron cloud. And these electrons are attached to the atom. They're bonded to the atom because the protons and the electrons attract each other. So they are bonded to the atom. However, they can be removed from the atom. And if you happen to be able to remove an electron from the atom, then you have created what's called an ion, which is an atom that has more or less, actually has a charge on it. Charges, atoms that are typical non-ionic atoms, those are neutral. Neutral meaning they don't have a charge, and the reason they don't have a charge is because they have equal numbers of electrons. This is the symbol we use for electron, the E with the negative, and protons, which will be the P with the positive. So a neutral atom has equal numbers. An ion has unequal numbers of electrons and protons. So this, I'm hoping this is all a review for you. So now we come to electricity and static electricity, which is kind of what we're going to be talking about for a while. With static electricity, we're going to be talking about taking electrons and adding them or subtracting them from particular objects. So we're going to move the electrons around. I want you to understand that. The protons, we're going to leave them alone because the protons are within the nucleus. And if we want to pull a proton out of the nucleus, that takes like an atomic bomb. And we don't want to have to do that every time we need to toast the toast in the morning. So we really just want to move electrons around. It's much, much easier and takes much less energy. And it's much less destructive if we just move around some electrons. So static electricity is going to be, it's going to be electrons that are basically placed in a location that don't move once we get them there. That's the static part. So we're going to be talking about electrons. That's really what we're going to be focusing on. And putting them on an object. And not allowing them really to move. And they stay there. So they're stationary. Once we start talking about moving electrons, that'll be a current, and that'll be more electricity and circuits and that sort of thing, and we'll get there. But for right now, we're going to take our electrons and we're going to place them on an object, and they're going to pretty much stay there. So the question is, how do we determine how much charge an object has? So that's really what we're going to be getting at. How do we determine an object's charge? If I happen to know how many electrons it has on it, how many excess electrons, how can we figure out what its charge is? In order to do that, we need to talk about what's the charge on an electron. Well, so let's actually begin by talking about charge. The symbol that we're going to use for charge is Q. And the unit is a unit you haven't seen before. It's called a coulomb. At least you haven't seen it in my class. You might have seen it in chemistry. The symbol we're going to use for coulomb is a C. So all charges are going to be denoted by the letter Q, and their units are going to be in coulombs, which is the letter C. And for an electron, electrons happen to have a charge that we know about. We have a special name for the charge on an electron. It's called, the name we call it is the elementary charge, because it's the smallest charge possible, because you can't get anything, you can't split an electron in half and get half of an electron. So the elementary, because elementary school is where you send kids, little kids, well, elementary charge is the smallest charge. And we happen to know that the elementary charge, the charge on an electron, whose symbol we're going to use as QE for elementary charge, is 1.6 times 10 to the minus 19 coulombs. So that's the charge on a single electron. It also happens that the charge on a proton, which is also equal to the charge on an electron, is also 1.6 times 10 to the minus 19 coulombs. The only difference, and I should go back and let you know that the charge on an electron is negative and the charge on a proton is positive. So that's really the only difference. They're the same amount, they're just oppositely charged. So if I have an object, let's suppose a metal sphere, and I have on that object 5 extra protons. So I've removed 5 electrons from this object, and now this object has 5 excess protons. I can figure out how much charge that object has, because its amount of charge will be equal to its 5 protons times the charge on a single proton, times the elementary charge. So that would be 5 times 1.6 times 10 to the minus 19 coulombs. And that's the amount of charge that would be on on that particular object that had 5 excess protons. So you can get your calculators out, which I'm sure you have all ready to go. And you can, just like I had my calculator ready to go, you can put in this number, and you can find that the charge on that specific object that has 5 excess protons would be 8 times 10 to the negative 19 coulombs. So that's how you would figure out the charge on that particular object. Likewise, let's suppose I had an object where instead of taking away electrons, I put on, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9 excess electrons. So I added some electrons onto this object, and I want to figure out what its charge is. Well, I can figure out its charge by just taking the 9 times the charge on a single electron. So that's going to be 9 times negative 1.6 times 10 to the negative 19 coulombs. And I can figure that out. So I would just plug that into my calculator, and I would end up with a negative 1.44 times 10 to the minus 18 coulombs. So that would be the charge on that specific object. So all in all, very easy. Unfortunately, it usually doesn't stay this easy because we don't usually deal with small numbers of electrons and protons. We usually deal with very large numbers. So let's suppose I told you, for example, let's try an example of those. Let's suppose I told you that I had an object, we'll do a box this time, and this box had 5 times 10 to the 13 extra protons on it. So it's got 5 times 10 to the 13 extra protons than electrons. So if I wanted to figure out the charge of that one, I would just use the number of excess protons times the charge on a proton, just like I did up here, except it's just that the number of the excess protons is a lot more complicated than just 5. It happens to be 5 times 10 to the 13th. I still multiply that times the charge on a single proton. So when I multiply those two numbers together in my calculator, 5 times 10 to the 13th times 1.6 times 10 to the minus 19th, I get 8 times 10 to the minus 6 coulombs. Okay? So you can kind of see that that's pretty much how we're going to be working these. The only other little tidbit is that sometimes I don't actually give you the number of excess. Instead, I give you this charge to begin with. I might say, for example, if I had a silver dollar and I wanted to give it a charge of 2.4 microcoulombs, how many excess protons would it need to have in order to have a charge of 2.4 microcoulombs? So in that case, the charge is 2.4 microcoulombs. And I want to know how many excess. That's the question mark. So if I look at this formula that I've drawn right here, in this case, I'm given this number on the left, and I'm asking for the number of excess. So that's what that's how that's gonna end up working. Okay, so the charge, pardon me, I was interrupted. The charge, which is 2.4 microcoulombs, we're gonna write that as 2.4, and we have to look up micro. Micro is a 10 to the minus 6 coulombs. So that's what we're gonna put on the left-hand side. We're going to solve for the number of excess protons in this case, and then we're going to plug in the charge of a proton. So we'll put 2.4 times 10 to the minus 6 coulombs. Let's see if that's going to work. There we go. Equals the number of excess protons times the charge on a single proton, which is 1.6 times 10 to the minus 19 coulombs. Okay? So that's my formula. Now to solve for the number of excess, I have to divide this out. So you're going to plug that in your calculator. 2.4 times 10 to the minus 6 divided by 1.6 times 10 to the minus 19 gets you 1.5 times 10 to the 13 protons. So that's how many protons you would need in order to create this charge of 2.4 times 10 to the minus 6 coulombs, or 2.4 microcoulombs. Another way of saying this is we would need to remove from that box, in order to create this charge, we would need to remove 1.5 times 10 to the 13th electrons. Because if we removed those electrons, we would leave behind an excess of 1.5 times 10 to the 13th protons, since the box originally began neutral, meaning it had equal numbers of protons and neutrons. So for every time I remove an electron, I leave a proton behind. So if I remove this many electrons, I leave this many protons behind. Okay? So that's the general idea behind this formula. Now the last little thing is that I'm going to kind of make the formula look a little bit neater. I'm going to use Q on the left-hand side, like we've been doing, the charge. In place of number of excess protons, number of excess electrons, I don't want to have to write that anymore, so I'm going to assign that a letter. I'm going to assign it a capital N. And then for the elementary charge, I'm just going to call that QE. So that's how this formula is now going to look. So Q is the charge on the object. It's going to be in coulombs. N is now going to be my number of excess protons or electrons, whichever one we're dealing with. And QE is going to be the elementary charge. And that's going to be a number you always know. I don't know what happened with elementary there. That's always going to be plus or minus 1.6 times 10 to the minus 19 coulombs. Okay, so that's it. So there's your notes. I've left a worksheet for you. I want you to try the problems. You do not have to do problem number 5 on the worksheet. Don't cross it out, but you just don't have to do it today. But you need to do 1 through 4 and problem number 6. And I will see you tomorrow.